Hello and welcome to the Core Learning. Today we're diving into a full walk.
Hey guys, so today I'm going to be looking at how to derive the quadratic formula. As a reminder, a quadratic equation takes the form ax squared plus bx plus c, where a, b, and c will all just be integers, which will be equal to 0. So, as a reminder, the quadratic formula itself is that x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. So we're going to try and work out how to derive this from our original generic quadratic expression on the first line. So the first thing we would do is for this ax squared plus bx plus c, we're going to divide through by a just to get x squared by itself. So this would give us x squared plus b over ax plus c over a is equal to 0. At this point, what we would do is called completing the square. Now, if you don't know how to complete the square, I'd suggest going and watching a video on it. But as a quick recap, if you haven't done it before, let's say, for instance, we had x squared plus 4x plus 8. The way we complete the square is we take half of the x coefficient. So we'd write out a bracket and we'd have, in this case, x plus, and it would be half the x coefficient, so x plus 2 squared, and then we'd have to work out what goes on the end to make it equivalent to the original quadratic expression. So in this case, if we were to fully work out x plus 2 all squared, which I will do, that gives us x squared plus 2x, which is 4x. So you can see these two parts start off the same, which is why we do it. And then we'd have 2 times 2 on the end, which is 4. So this is what the x plus 2 squared bracket is equal to. So to get back to the original expression, which is plus 8, not plus 4, we just have to add another 4 on the end. So this is how we do it as a simple example. And we want to apply that to our generic expression. So the way we would do this is we start with our bracket, x plus. Now, our x term has a coefficient of b over a. So what's half of b over a? It's going to be b over 2a. So we have x plus b over 2a all squared. And then we have plus, and I'm going to call it y. So we've got to work out what this y value is. And just for completeness, make sure it's equal to 0. So what we are comparing is this, and we are comparing this to, and in fact, let me just get rid of that. We are comparing this to x squared plus b over ax plus c over a. Now, we know that when we expand this bracket here, we're going to get x squared plus b over ax, because that will always be the case when we put in half of the x coefficient here. It'll always give us this first part correct. Then we're going to have b over 2a squared at the end. So b over 2a squared is b squared over 4a squared. Let me just move up here. Over 4a squared. Now, when I'm doing this, like I'm so used to expanding brackets, I can kind of visualize what we're going to get for each part of the expansion. But if you're a little bit unsure, you haven't really done it too much, I'd suggest just fully expanding it out just to check that what I'm doing makes sense. So once we've got this, we have our x squared plus b over ax plus b squared over 4a squared plus y. And this is equal to x squared plus b over ax plus c over a. Now you can see, obviously, the first two parts here are the same. So we can just cross these out for now. And what we really want to work out here is this y value. So we're going to set y equal to, and it's going to be c over a minus b squared over 4a squared. So we've isolated the y. What we want to do now is we want to make the denominators of both fractions the same so that we can combine this into a single fraction. So if we multiply the c over a, if we multiply top and bottom of c over a by 4a, so let me just write that out to be explicit. So we multiply 4a over 4a times c over a minus b squared over 4a squared. This is going to give us 4ac over 4a squared minus b squared over 4a squared. And now that we have the same denominator, we can simply evaluate the numerator and we get 4ac minus b squared all over 4a squared. So, and just a reminder, this is our value of y. So let's just remind ourselves what we originally had. We had x plus b over 2a all squared plus y. That is how we now want to write this generic expression, quadratic expression. So we have x plus b over, not b over a, b over 2a, all squared, plus y, which is 4ac minus b squared over 4a squared. And this is equal to 0. Now that it's in this form, it's going to be a lot simpler to solve. So how do we start? So the first thing I'm going to do, and hopefully this is going to make it a little bit easier. Well, I'll tell you what I'll first do. Let's get the x term on one side and then that y term on the other. So when I say that y term, that 4ac minus b squared over 4a squared. So we have x plus b over 2a squared equals minus 4ac minus b squared over 4a squared. Now, what we can do here is if we have minus times both components, we can switch that around. So we can have, this is equivalent to plus b squared minus 4ac over 4a squared. What we want to do next is get rid of this square term on the left-hand side. So if we take the square root of x plus b over 2a all squared, and we take the square root of b squared minus 4ac over 4a squared. Clear, that's the full thing. So in this case, if we take the square root of a square, it just cancels out the square, and we're just left with x plus b over 2a. And we have the square root of, actually, so what we can do here is, I'll just write this on the side. So this square root on the right-hand side, so we have the square root of b squared minus 4ac over 4a squared. If you remember anything about the rules of square root, we can rewrite this as the square root of b squared minus 4ac over square root of 4a squared. And if we do this, the square root of 4a squared is 2a. So we can simplify this. So we now have x plus b over 2a is equal to the square root of b squared minus 4ac. Hopefully you might be able to see we're getting quite close to the quadratic formula over 2a. And now all we need to do, now this is something I should have been clear on, and I realised I've missed. When we find the square root, the values we can allow are plus or minus of that value. So for instance, let me just be careful to explain that. So if we have the square root of 9, our two answers are plus or minus 3, because 3 times 3 is 9, and minus 3 times minus 3 is 9. So I'm just going to be careful here to put this plus or minus. Now what we can do, we can finally isolate the x. So we have x is equal to minus b over 2a plus or minus the square root of b squared minus 4ac over 2a. And you can see we have the same denominator for both terms on the right-hand side. So we can combine this into a single fraction, and we get minus b plus or minus the square root of b squared minus 4ac over 2a, which is our quadratic formula.